Hi! Today I'm going to be doing the experiment of hydrogen peroxide decomposition. This is commonly known as the elephant's toothpaste experiment, but I will not be adding any soap to it to make it bubble up loads. Another thing that's different between it is you would usually use potassium iodide. I don't have any left, so I will be using two different compounds, and I will be timing them to see how fast they will react. Right, experiment. We will do each iteration 3 times for each chemical, and we will record the time and take an average to see how fast they react. We will be doing it with 12% hydrogen peroxide, potassium permanganate and potassium nitrate. I synthesized the potassium nitrate myself, and I will show a video on how to make it in a bit. We'll be carrying it all out in this one beaker, which I will clean between uses, and we'll be measuring with the cylinder and scales. We will take the thermometer reading just because temperature does have a slight effect. In this beaker here we have 1 gram of potassium permanganate dissolved in 50 milliliters of water. I've taken the temperature reading as 21 degrees Celsius, and I will put the molarity up on screen now. Great. This is the solution of 12% hydrogen peroxide, and I will be pouring quickly into that whilst I take the time. Okay. I don't know how visible that was, but the solution is still very purple, meaning there's a lot of potassium permanganate still dissolved in it, and whilst it's splashed, there's all this brown stuff on the walls of the beaker. That is manganese dioxide that is produced in the breakdown of potassium permanganate. I'll put the equation up now. Great. That's what happens with potassium permanganate. Okay, I have cleaned out the beaker, and I have added 50 milliliters of water and 1 gram of potassium permanganate to the solution. This has a concentration of, when I calculate it, that's the molarity. This is again 10 milliliters of 12% hydrogen peroxide, and let's do the experiments again. Nothing happened. Just as a quick check, I'm going to add a small sprinkle of potassium permanganate into it. Okay, so potassium nitrate does not work for this experiment. Try and figure out why now. Okay, so my final answer for why it's not working is, I don't know. But whilst I was doing a bit of research, I was trying to figure out what you could do, what else you could do with some hydrogen peroxide, and I found a few other interesting parts for chemicals you can mix with it. Let's do it. This beaker contains just over 1 gram of iron 2 sulfate and a little over 50 milliliters of water, because I went a bit over. This contains about 10 milliliters of hydrogen peroxide. Let's go. This reaction has been going for about 5 minutes, so I'm going to start the next one and put it to the side. For this experiment, the hydrogen peroxide is already in the beaker, and I will be adding small amounts of sodium thiosulfate. This is highly crystalline and pure, and you should notice something very interesting. I'll do that one more time with a much larger piece. and finally one more time. What just happened was the sodium thiosulfate went into solution and very quickly deionized into the solution, and that allowed it to break apart. That extra heat allowed it to dissolve even faster, so it quickly broke down. I reckon there's quite a lot of hydrogen peroxide still left in there, so I'm going to move on and add in some manganese dioxide, because I know this does something. This is a much slower oxidizing agent than the potassium permanganate, and as mentioned before, it's actually produced in the decomposition of it. For this reason, you should not add potassium permanganate solution directly to hydrogen peroxide. You should add the hydrogen peroxide. Oh, it's spilling over, great. You should add the hydrogen peroxide. Oh wow, it's still going. I'll clean this up in a bit. The hydrogen peroxide should be added to the potassium permanganate, because the manganese dioxide can change the results you'd be expecting. This beaker has finally settled, and right at the bottom, that's barely visible, we have a small precipitate of some, what I presume to be iron 3 oxide. That pretty much ends this experiment. Kind of failed, so I just messed around with chemistry for a bit. Yeah, bye.